Hello me, this is the Kerberos 101 video for you to refresh all your knowledge on Kerberos. I'm going to use this official website from the Kerberos consortium, and in particular I'm going to use this tutorial, which I believe is very easy to follow and to understand. I'm not going to cover everything in detail, but I will go through the first 4 sections. At this point I will stop and I will jump into the artifacts that I have created for you to have a demo environment up and running. And that's going to help you to play around with all the concepts that we introduce here. That's going to be helpful and you will understand everything much better. Without any further ado, I will go straight to the introduction and I will let you know what Kerberos is. Kerberos is an authentication protocol for trusted hosts on untrusted networks. Kerberos assumes that the application servers where your services are running are properly secured, meaning that if someone is not authorized to access that server, that will not happen. If that happens, it would be a problem because it could get this secret key and that would compromise the service itself. When it comes to the network, Kerberos assumes that the networks are untrusted in the sense that there will be some computers that are out of your control, are out of control of the administrators of the company. However, there will be some users on those computers trying to get access to services that are available in your application servers, in your trusted hosts. That's not a problem. From the authentication perspective, Kerberos is going to take care of the identity of the users and the identity of the services. So everything is going to be trusted, everything is going to be authenticated, and the services and the clients can be sure that they are talking to the right entity. Here we have some features about Kerberos, and I'm going to summarize them in 3 points. The first one is about users' passwords. They never go through the network. They are not stored in the client side, and as soon as they are used, they are discarded. From the authentication server perspective, they are always stored encrypted. Otherwise, that would be a security risk. The second point is about the single sign-on experience brought by Kerberos. And this allows the end user to provide the username and password once or twice a day. And even though they are accessing different services within the organization, the authentication against those services are going to happen automatically. So Kerberos underneath is going to do all the hard work. Last but not least is the mutual authentication. So in Kerberos, it is not only the user having to demonstrate their identity to the application server, but the other way around. So the client, the user, wants to be sure that it is using the right service. So it is not something that a malicious user has installed somewhere and is trying to grab the critical information. Now I'm going to detail the different components and terms in Kerberos. This is not difficult, but there are many and you need to connect all of them properly in order to understand things. First of all, I'm going to go over all the elements and then I will expand each one. So the first element I'm going to introduce is the realm. Realm is an administrative domain and it's going to encompass the rest of the elements that I will present in a moment. Principals are related to users and services. Tickets are used to demonstrate identity, so you can think of tickets as the tickets that you use in real life to get trains, for instance, or airplanes. Then I will talk about encryption, and something that is very important to know about Kerberos is that it uses symmetrical key encryption. Symmetrical key encryption means the same key is used for encryption and decryption. And we will see how this is done, and we will see that there are different types of keys. There are keys for users, there are keys for services, and there are session keys. We will see in a moment where they are used. So we will spend some time on encryption keys, and encryption keys are the keys for the users, and we will see how the encryption key is created from the user's password. Then we will go straight to the key distribution center, which is the real name that we have to talk about when we are describing Kerberos. It is not only the authentication server, we will see that there are some additional components. Then the session key, which is a key used by client and services once they are authenticated. We will see the authenticator and the replay cache, which are artifacts that help to avoid man-in-the-middle kind of attacks. And finally, the credential cache, which is used to provide single sign-on features. So as you can see, there are many items here that we need to elaborate and connect to each other. So let's go back to the beginning. We have the realm, as I mentioned before. This is an authentication administrative domain, and it is used to encompass the rest of the elements that I've introduced. So a realm has a name, and this name is linked to the DNS domain name. If, for instance, your company has the following DNS domain name, example.com, the realm name would be example.com, but all uppercase. And when you are working with large organization, it happens that there is segmentation. There are different departments, business divisions, and all those things. And oftentimes they have, or they want to have, their own administrative domain. Therefore, they will need their own authentication administrative domain. And that's fine in Kerberos. So you could have different realms for different segments within the organization. But the challenge is when a user from a realm wants to get access to a service from a different realm. That's fine in Kerberos, and that's addressed by something called cross-authentication. That's something I'm not going to cover in this video because this is an advanced feature, but you must know that this is feasible. If you need it, just go straight to this section and elaborate some more. Principals, as I said before, are related to users and services and are entries in the authentication server database. Principals have names, and names follow this pattern. There are two well-differentiated parts. The first one is the components. All of them are separated by slashes. And the second part is the realm name. Both are separated by an @ symbol. In practice, you will see up to two components. And when it comes to users, this is the kind of principal name that you are going to face. First component is going to be the username. Second component is going to be the instance. And the instance is something used to better qualify the type of user. You, as an employee of a company, it's very likely that you have different roles. If you work in IT, probably you are looking after some systems and you have some administrative rights. If you access that server to do some maintenance tasks, you will need to use a principal, which is representing yourself with additional privileges. So the server is going to allow you to do so. In that case, you will have a principal with your username and potentially an instance like admin. But when you are accessing to the email server, in order to authenticate yourself with normal privileges, just to get your email, you will use a different principal name. Probably it's just your name, username @realm. For services is very similar. You have two components. The first one is the service name, the second one is the host name, and for the host name it is used the full qualified domain name for that host name. And here you have some examples. This line is the principal name for an IMAP server. IMAP is the name of the service. mbox.example.com is the host name, full qualified domain name. And actually example.com is the domain name, which is pretty much the same as the real name, but lowercase. Cool, now we are going to cover ticket. So ticket is something a little bit tricky to understand, but I'm going to bring an example to the table just to make it easier. So let's see what happens. So the ticket, long story short, is something a client has to present to the application server to demonstrate the identity. So let's think of a client, let's say myself, Raul, is accessing to a MongoDB server to run some queries. And those queries are going to provide some insights to Raul. So the first question is, how does Raul get a ticket? Okay, the ticket is going to be issued by the authentication server. So there's going to be a first stage where Raul is going to start an authentication request against the authentication server. If everything goes well, it will get a ticket to use with the MongoDB server, and this ticket proves that Raul is an authenticated user within the system. So Raul is very curious, and he's going to look into this ticket because he wants to understand what's underneath. But what happens is this ticket is encrypted, and Raul doesn't have the key to decrypt it. So the authentication server is going to use the secret key of the service. So here you can realize that the secret key of the service is shared between the application servers, in this case MongoDB, and the authentication server. So again, the ticket is encrypted with this secret key. Raul presents this ticket to the application server, to MongoDB. So MongoDB gets the ticket, and MongoDB is able to get into this information because it has the secret key for the service. It will get the user's principal, basically the username. It will get its own principal name. It will get the IP addresses of the client, and this is not mandatory in the latest version of Kerberos. And then there will be some timestamps, lifetime, and some other artifacts to prevent the client having access forever to the application server, to the service. Finally, there is a session key. This session key is going to be really important to guarantee that interaction between the client and the service in a secured way. Okay, so next point I'm going to cover is encryption, and specifically the encryption key, which is related to the user. And let's discuss just a little bit how to come up with an encryption key. So okay, the user will have a password, that's fine, but it happens that the encryption algorithms use keys with a fixed length. So that means the password cannot be the key, because every single user will have different passwords with different length. So we discard that. So what we can do is to use a function getting this user's password or taking it as an input, doing something and providing a result with the same length. And this is what we are going to call key. And these kind of functions are called hash functions, and they are used everywhere in systems. MD5, CRC32, SHA-1 are examples of hash functions. Okay, that's fine. So every user's password is going to be transformed by this hash function. We will have a key But the problem here, the issue is that if we have two users with the same password, both are going to use the same encryption key, and that's not desired at all. So Kerberos 5 introduced the concept of password salt, and this password salt is just about complementing this user's password with something else which is unique for the user. So that is the principal name. So if you concatenate the user's password with the principal name and you apply the hash function, you will come up with the encryption key for the user. And this is going to be shared between the user, it's going to be in user's mind, and the authentication server. And then we have the concept of key version number. Every time a user changes the password or an administrator changes the service password, this number is incremented. Okay, so finally we get to this point where we are going to talk about the real components that you are going to find in a Kerberos environment. So the Kerberos environment is going to be called Key Distribution Center, or KDC, and so the name is coming from the ability of the system to distribute tickets across the different users to allow access to the services. So the KDC is made of three key parts: the database, where all the information is going to reside; the authentication server, which is going to take one of the steps that we have been described so far; and finally the ticket granting server, which is going to be responsible of providing service tickets. The database is going to be a database containing entries for the users and services. So it's going to contain the principals and some additional information. It will contain the encryption key for the user and for the service, and the key version number. It will have some additional information, validity, lifetime, expiration dates, some flags, so everything that is needed to make the system robust. This database is encrypted with a master key. The master key is a key that you have to provide when you are installing Kerberos, and it has this principal associated. So the database itself is encrypted, but when you are doing exports of the database for backups or for propagation to have the same information in a secondary KDC, everything is going to be encrypted with this master key. The other component is the authentication server, and so this is the component getting the authentication request from clients, and it's going to provide a very specific ticket called TGT, ticket granting ticket, which is a kind of VIP ticket, and that's going to be used by the client to get service tickets. This TGT ticket is going to have this principal associated. And last but not least is the ticket granting server, which is going to be responsible of delivering service tickets. We will come back later to these elements. Now it's time to cover the session key. So the session key is something that is shared between the users and the services, and it is as specific for that interaction. So it's going to be a secret key between the two elements, but it has nothing to do with the encryption key and the secret key for the service. Those are long-term keys, while this is a short-term key. Let's talk about the authenticator and the replay cache. So under these circumstances, it might happen that we have a third-party entity just sniffing all the traffic and trying to reproduce what a client is doing in order to get access to the service. And in order to prevent this situation, Kerberos introduced the authenticator concept. And this is a way of making the client something that is unique from him, and this unique thing is going to reach out to the service and is going to give some additional guarantees that the application server is talking to the client itself and not to someone else. And in order to build this authenticator, the client uses the principal and the timestamp, and this information is encrypted with the session key. So here you see that session key is used many times, and this is the first time that is used to guarantee that the application server is getting access or is allowing access to the right client. And so when this authenticator arrives to the service or the application server, the timestamp is compared to the local clock. And so if differs from the application server's clock in 2 minutes, that's fine. But if go longer than that, then that means something happened. So you can understand by this fact that clocks synchronizations are important in Kerberos. And replay cache is pretty much the same. So it is preventing someone to reuse packets or requests in order to get access to the service. So the application server is having those requests in a cache for 2 minutes in order to prevent having the same response twice. So it assumes that in 2 minutes it's impossible for an attacker to reproduce the same requests. Finally, the credential cache is the way of implementing the single sign-on characteristic, and that's pretty much all. Now I'm going to cover the Kerberos operation. So I'm going to go over this scenario, and again I'm going to use the example I introduced before. The client is going to be myself accessing to a MongoDB server to run some queries and get some insights. And as you can see, there are going to be many different interactions with the KTC. Inside the KTC we have the 3 components that I was describing in a moment ago. We have the authentication server, we have the ticket granting server, and the database. The first thing that we are going to see in this scenario is an authentication server request, and the request contains these elements: the principal of the client, the principal of role, the principal of the service the client wants to access to. In this scenario is going to be MongoDB. The IP lists is the list of IP addresses that the ticket can be used from, and the lifetime of the requests. Okay, so this is sent to the authentication server. The authentication server is going to reply back with a ticket and a session key. So the ticket is going to be the TGT, and the TGT is going to be encrypted with the secret key from the TGS. The session key is going to be encrypted with the client encryption key. Okay, so this is the information that the client gets from the authentication server. Next step is the client to request the service to the MongoDB, the ticket to the MongoDB service. So this request goes through the TGS request. It presents the TGT, which is encrypted with the TGS secret key, and the client is going to create the authenticator with the session key created by the authentication service. So through this line there will be the TGT and the authenticator traveling to the TGS. So here everything is decrypted, all the check-ins are done, and if everything goes well, what is going to happen is the TGS is going to give back ticket, service ticket for accessing the application server, but it will also provide a session key for the interaction with the service. Next step is the client, myself, is sending the service key with an authenticator using the new session key for this interaction, and this will go to the application server. So the application server, MongoDB server, will use all this information. It will validate that everything goes okay, and it will reply back. And this reply back is going to be used by myself, by the client, to be sure that the application server I'm accessing to is the right application server and it is not something else. So as you can see, this is obviously very simplified. There are some nuances underneath, but those are not going to be covered in this video. And something else that is important to highlight is the pre-authentication. So that's something that I found in many different tutorials and installation guides. And so if you go deeper to the whole process, you will realize that there is no pre-authentication. So basically the user, when is accessing the authentication server for the tickets, it gets everything. So the only check-ins the authentication server does is against the database. And so if everything is in the database, if the principal exists in the database, the whole process move on. That's not a security issue, because actually if the user doesn't have the encryption key, at some point the user is not going to be able to move forward. But it could be applying this brute force attack kind of algorithms in order to get into the encrypted information, and once the user, this attacker, has the secret key, maybe it can start doing some unauthorized access. And so in order to prevent this situation, pre-authentication has been introduced in Kerberos. And so this is just a previous step to everything that I was mentioning before. And this is described over here. So when you enable pre-authentication, what happens at the very beginning, when the user is interacting with the authentication error, the authentication error replies with an error. And so this is just requesting pre-authentication. So when this error is coming, the user has to provide the password, and so that means it is creating the encryption key, and so you can encrypt whatever it is. And so what it's doing is just encrypting the timestamp with the long-term key, which is the encryption key, and that's used by the authentication server to ensure that the client is a proper client. So that's something that I didn't know, and so I realized afterwards, and I think it's important at least to understand what the pre-authentication thing is. Okay, so and this is it. Now I will jump into the demo environment, all the artifacts first and then the demo environment. Okay, and this is what I have prepared for you to be able to reproduce everything that we have covered so far. And as you can see, this is available in the GitHub repo, and this is under collaterals, knowledge, Dockerized Hadoop core Kerberos 5. And what I'm providing, it's a Dockerized environment to run a Kerberos server. So it's going to run the KDC I was mentioning before and some additional utilities. So the first file I'm going to cover is the Docker file. So here is everything described in order to install Kerberos 5 on a Linux machine. And so the steps are very easy. You install the packages, you copy the configuration files, you execute some scripts to create the Kerberos database and to create a principal for the administrator user, and finally define the script to execute the KDC daemon and the Kerberos admin daemon, and so these ports are exposed to the outside world. So here you have some additional resources that you might be interested in going over. This one is the tutorial that I've been followed. So very quickly, this is a configuration file where I'm saying that this principal username admin with role admin for this realm has full access to everything. So it's the power user. This is the KDC configuration file. This is the configuration file for the KDC daemon. And so here you have the ports where the KDC daemon is bound and waiting for requests. This is the configuration of the realm. As I said before, this is the real name is matching the DNS domain name, but everything is uppercase, so that means the DNS domain name has to be the same but lowercase, and you will see this when I execute the container. Then we have the path to the database. This is the secret key for the service. The service is the admin, the Kerberos administrator service, and we have some additional elements that I'm not going to cover right now. But so here you can see the pre-authentication that I was mentioning before, and this is for login purposes. And this is the KRB5 conf file that you need to use for the Kerberos clients. We are going to use the same machine as Kerberos server and Kerberos client, but when we make some other videos where we have different machines, this file needs to be in the client machine as well. And so here you have what is the default realm, and it matches the realm that I was showing before. And here you have the details about the realm where the KDC is located. So this is the name, the host name of the Kerberos daemon, the Kerberos server, and you can see very easily that the DNS domain name matches the real name, the administrator server, and this is the default domain. The bootstrap is the script that is executed when the container is up and running, and so it executes the KDC daemon and the Kerberos admin server daemon. And finally, the scripts. I'm using spec to execute those commands in an automated fashion. This script is, this script is creating the Kerberos database, and this is the command. As you can see, I'm creating the database for this realm, and it is asking for the password, the master key, and this is the master key. And finally, the script for creating the principal for the administrator, the Kerberos administrator. So we use kadmin local to short circuit the authentication steps, and we execute this command. So we create the admin user with admin role. This is the instance, and here we have the realm. It asks for a password, and this is the password. So everything is in the Docker file comments. So here you have everything to build the image by yourself, but I already did it for you, so you are not going to need to spend a lot of time on this. So you go to my Docker Hub account. There are many repositories, and one of them is the Romarin Perez /Kerberos 5, and here you have all the details to make it work. So what I was showing before, the database master key is this one. So this is taken from the installation guide. So even though it looks like a very secure password, it is not. And so this is the password for the principal the administrator user principal. Okay, this is something that you will need when you want to make this image work with some other additional images, but that's gonna be for a different video. In this case, what we are going to do is the following. I'm not going to build the image, but I'm going to pull the image and I'm going to install it in my local computer. So we are going to use docker pull romarin pares / Kerberos 5 : and the tag, and we are going to use latest. So I already downloaded just to make this video shorter, and so I'm going to check that everything is there, and there you go. And next thing is execute this image just to create the container. Once it is created, we will access to it, and finally we will kill it. We are going to create the container this way, deattach it. Once is finished, it's going to be removed. This is the host, this is the name of the container, sorry, the host name, the domain name, and finally the image, docker image name. We copy this, we paste it. You can display the logs if you want. This is gonna be very fast, so maybe it doesn't make very much sense, but so this is going to give you an idea that everything is up and running, and now we can access the container very quickly. And we are inside the container, and here you can start using Kerberos very quickly. You can use the client applications like klist to list all the tickets available, nothing is there, or you could use kinit to initiate an authentication. Then you can provide a principal, or you can provide a GitHub, and that's something that I'm not going to do in this video, but in a different one. And so we are going to use the only principal that we have, admin queen krb tests. It will ask for the password. We will provide it. And this will create the TGT ticket that we mentioned before. So you can see we list the tickets that we have. This is the default principal, and this is the ticket that we have. Is the ticket provided by this principal. This is the principal associated to the TGS. Okay, and that's everything that I wanted to show. In coming videos, I will use Kerberos from a client perspective with services, and it's going to be more elaborated. This is just Kerberos 101, and this is the image that you have to play around with Kerberos. So I hope this is handy for you to refresh the knowledge quickly, so it will take half an hour or something, which is much faster than going over the documentation notes and all those things. By me.